Hello and welcome to the first day of Chapter 10. We're going to be working with graphing quadratic equations today. So first of all, I'm just going to go over a couple old review concepts. Slope-intercept form, that's when we worked with lines. And we had y equals mx plus b. Then we did exponentials, y equals a times b to the power of x. And now we're working with the new type of function, the quadratic function. And that's ax squared plus bx plus c. We've talked about this in chapter 9 a lot. We've seen a lot of this, seen a lot of quadratics actually, but we're actually going to graph them. Today we're going to work with simple quadratics where b is equal to 0, so ax squared plus c. So these are going to be a little easier to graph, and we're going to talk about transformations. We'll talk about domain and range, a lot of things that we've talked about in the past. We're just going to apply it to a new function. Okay, so we're going to be graphing simple quadratic functions, basically b equals 0 here. All right, let's start by graphing the parent. This is our parent function. It's the most basic quadratic. What you're going to do, make a table of values, 0, 1, 2, -1, -2. And what we're graphing is y equals x squared, so we're just taking numbers and we're squaring them. 0 squared is 0, 1 squared is 1, 2 squared is 4. If you want to do 3 squared, it gives you 9. -1 squared is 1, -2 squared is 4. And then you're going to plot your points here. My scale is going by 2's, just so you guys are aware here. And it's going to create a graph that looks kind of like a U. And there is your first quadratic equation. And we can do tons of these. I'm going to go over the vocab, and then we're going to kind of go through graphing a few more. So a quadratic function is a nonlinear function. It's not a line. It's a U-shaped. That can be written in the form ax squared plus bx plus c, where a does not equal 0. B can be 0, c can be 0, but a isn't going to be 0. If a was 0, it just turns into a line. So then it wouldn't be a quadratic. So this U-shaped graph that I've been talking about is called a parabola. Not parabola, a parabola. In this lesson, we're just going to graph simple quadratics. Now the parent function, this is what we just did. We just graphed y equals x squared. That is the parent function. The lowest point or the highest point, because we can reflect these and we'll see that in a little bit, is called the vertex. Okay? And this invisible line here that the graph is symmetrical about is called the axis of symmetry. And we're going to figure out later on how to figure out where that line is if b is not equal to 0. If b equals 0, it's always going to be on the y-axis. Okay, so let's graph some of these. I'm going to use 0, 1, 2, -1, -2. I generally use these numbers here when b is equal to 0. So we're going to square 0, then multiply it by 3. We'll square 1, multiply it by 3. We'll square 2 to get 4, multiply it by 3 gives you 12. Square -1 to get 1 times 3 is 3. And square -2 to get 4, multiply it by 3 is 12. So you notice I'm doing the exponent first. And this is going to create the graph to be much skinnier. And so if I plot my points, you'll see that this graph is much skinnier. This is our vertical stretch of 3. Okay, we talked about vertical stretch. This 3 creates it to be skinnier because you're multiplying it by 3 every time. All right, let's take a look at -1/4 x squared and see what that does to the graph. Now you're going to notice here that I chose 0, 2, and 4 instead of 1, 0, 1, and 3. And the reason for that is because I'm multiplying the values by 1/4, and so it's going to make the numbers easier to work with. So when I plug in 0 squared, 0, 0 times anything is 0. Plug in 2 squared is 4. 4 times -1/4 is -1. Plug in 4, square that is 16. 16 times -1/4 is -4. And the nice thing about these is that they are symmetrical. And so if you plug in the values that is symmetrical about, you get the same numbers. So anyway, 0, 0, 2, -1, and 4, -4. So you're going to notice this parabola is much wider than, oops, it should be right there. This parabola is much wider than the other one. And the reason for that is the 1/4. This is a vertical shrink. You're also going to notice that this is flipped upside down. It is a reflection. So we have a vertical shrink and we have a reflection. So there you go, a couple vocab words we've seen in the past. Okay, let's see. This plus 5 here, we're going to do x squared plus 5. So we're gonna make the graph, and then we're going to compare them. We're just going to graph. We're just going to do one of these. We're just going to do x and y. Okay, so we'll do our normal points here, 0, 1, 2, -1, -2. And we're going to square x and then add 5 to it. So 0 plus 5 is 5. 1 squared is 1 plus 5 is 6. 2 squared is 4 plus 5 is 9. And then -1 squared is 1 plus 5 is 6. -2 squared is 4 plus 5 is 9. And so you're going to notice here with this graph when I plot it, it's the same graph as the parent function. It's just shifted up 5 units, that's all. So this is a vertical translation, meaning I'm moving it up. Vertical translation up 5 units. That's what the plus 5 is going to do to the graph. You can do all kinds of these. The -4 is going to be a reflection with a vertical stretch. The 1/3 is going to be a vertical shrink. The plus 2 is going to be a vertical translation up 2 units. And like I said, you could do these for days. So this one here, we're going to have this is going to go down 4 units. That's what this -4 is going to do. And this is going to be a vertical shrink of 1/2 because of the 1/2. So it's going to become wider. There you go. I'm not going to graph that because we've seen enough graphing. Here's what I just talked about. Vertical stretches and vertical shrinks, reflections, and vertical translations up and down. So that's what all that business is right there. And I'll use Desmos in class and kind of walk you guys through this, and we can plot some on Desmos. And then this is a fun question. How would the graph of the function x squared plus 6 be affected if the function were changed to x squared plus 2? This would go down 4 units because then it goes from 6 down to 2, so it's going to go down 4 units. And that'd be C. I'll talk about that in class. And there's your assignment. Thank you guys for tuning in to our